Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day. So in this video, I will explain two optimal approach with lesser time and space complexity. Now without further delay, let's start the video. The video flow will be this way. First I will explain the question, then go through the test case simulations to understand the questions better way. And third is I will give you the two optimal solutions, and for each solutions approach I will give you intuitions, algorithm, then code explanations, then go through the dry run, and then complexity analysis. And those two solutions will be using, first one is prefix and suffix sum, and second one is dp. So now let's start the video. So question is given as we are given a string s which is only consist of English letter a and b lowercase only. This consists of the string a, and we have to perform some task. The task is convert the string to the balanced string. Then what is the balanced string? Balanced string conditions is written over here. So in a string there is no such pair exist that you can say I comma j, where I less than j and s of I equal to b and s of j equal to a. That means let's say in a string this pair is like this is the string. So you can it is a 0 1 2. So this is the smallest index, like if you consider 0 and 1 or 0 or 2, and if you try to satisfy these conditions, then I less than j over here 0 less than 1, that is true, and s of I equal to b, that is also true, and s of j equal to a, and that is also true. So this is not a valid string, like this is not a balanced string. So what it mean is all the a in the left sides, then all the b in the right sides. That means if a string exists, let's say there is all a in the left side, and if the b is starting, then all the b is in the right sides. That means these are the all a, and these are the all b. This is a balanced substring. So this is the main conditions. Now we have to do the some operations on the string so that it will be balanced. So permissible operations is delete any characters, like as I already give this example baa. So how we can do it to balance this? Let's delete this character b, then only aa is given, and there is no such pair exist where b is before than a. So it's a valid substring. So we can delete any characters as we want. Now then what to give the output? Output is return the minimum deletions needed to convert the string balanced. So we have to perform the deletion operations, but we have to perform the minimum number of deletions so that the string will be balanced. If a string is already balanced, let's say this is the string aa and bb, so this is already balanced. Now do we need to perform any operations? No. Why? Because this is already balanced, so we have to perform zero deletions. So that would be the answer. So I think question part is clear, and now go through the simulate the test case. So you can consider this is the test case given over here, and is it balanced? No, it's not balanced. Why? Because if you consider these portions, it will be b first then a, it's not balanced. So what to do the balance? Let's write over here b a b b a b. So let's try to we have two options. Either we can delete b over here so that a would be counted. So let's delete b over here. So now it's b b and again a over here, so we can delete a to continue the b. So it will convert it as, so 0 1 2 3 4 5 6 7, these are the index. So if we delete 2 and 6th index, then what you will have answer is a and b b b. This is a valid substring, or you can say balanced string. And another operations can be done over here, that means b b a b. So if we want to take this b, so we have to delete all a from these positions. Let's say these are the split, you can consider this is all a and then all needs to be B. So we just delete these two positions, that you can say 0 1 2 3 4 5 6 7. So if we delete 3 and 6 positions, this will also give you the valid substring, that means A then all B, that means there are 4 B's. Yeah, so this is also a balanced substring. And if you want to do this way, let's say you want to, let's run again BB and AB, and you want that all A's. Yes, it's possible, that valid substring, that means you all delete all B, and you can delete this also, A and A, this is also balanced. And if you delete all A's, that means all B's are there, this is also balanced. But we need to do the minimum deletions so that we can do it optimally. So you can consider 3 6 also optimal and 2 6 also optimal. That means we need to do minimum deletions as 2, that we have to delete minimum 2 elements so that it will be balanced. Now come into the second example. So you can do this way, that means it is not valid because BBA, that means B is before A, that is not valid. So if we delete just these two B, then all A and then B, yes, it's valid. So how many needs to deletion is required? 2B. If you delete this A also, that is also be valid substring, that means all are B's or all are A's, that will be also valid, but minimum deletion should be the 2 over here. Now come into the constant part. So why I am showing you constant part, because over here you can get the time complexity part also. Like string length is 10 to the power 5, that means you are allowed to do operations something like big of n or big of n log n, this way, but you cannot do this write the code in n square, because it is not accepted. N square means 10 to the power 5 square, that will give you the 10 to the power 10, and in 1 second permissible operations is less than 10 to the power 8, that means less than or equal to 10 to the power 8. So this is the valid you can valid constraint. So according to this constraint, you can define what are the complexity you can allowed to accept the solutions in the LeetCode. And another is, I already said that may si will be either A or B in lowercase English letter. Now come into the first solution, that we can use suffix and prefix. So I will explain first how I get this idea that why we should use suffix or prefix. So you can consider this is an intuition part. So balanced, what it mean by balanced? Let's say a valid substring, that will be all A are the left side, then A, then you can consider all B in right side. That means you can consider this is a split where A to B transition happen. So that means all these positions is A and all these positions B. So before split all A, before then after split all B. So we just need to split the whole array, or you can string, you can say string. So we just need to do each split. So how many in this split also I have seen that understand how many split is possible. That means you can consider all these positions is A and all are B after split, and how many split can possible. So there is this split, like you can split first, that means 0 A is possible, and we are taking all B's from the right side of the split, and it's mean we are taking up to that, that means for whatever first positions, if it is A, then we can take that as our we take this as a otherwise if it is B, then we can simply delete it, because before split all have to be A, and after split we want all have to be B, and the last one is also possible, that means we taking all A's no B. So there are, if there are 1 2 3 4 5 elements, then 6 possible split are there. So that means you can consider n plus 1 split is possible, where first split is considering all B in the right side, and last split, then this one is consider all A in the left side. Now problem is to calculate the number of A before split and number of B after split. So let's say we just want to try to brute force over here. These are the elements, you can consider these are the characters in a string. So if we just want to split over here, we just want the count of number of a before split and number of b after split, and if we get those numbers, and we can like build a substring, like build a string. Let's say over here number of a is 1 and over here number of b is 2. That means number of a 1 and number of b 2, this is a substring of balanced. And if we subtract from the total length, that you can say n, from n minus count of a and minus count of b, we get the number of deletions required to convert this balanced substring. So yeah, so we have to count it efficiently so that we can get the accepted answer. Now how you can count it? So we can just pre-compute the number. So over here you get the idea of the prefix and suffix sums. Like what we do in the prefix sums, let's say there is an array or string you can consider, and string you can consider array of characters. So if we define an array, and what prefix sum does, it's just count sum from left to right or right to left. We from, if it is left to right, it will give you the prefix, or if it is right to left, it will define as suffix. So we just pre-compute the number of a count up to ith positions, and also pre-compute the b count from ith position to nth position. So this will the suffix b count, and this will be the prefix a count. Now come into the algorithm part. So as I already discussed, first let's build the prefix for the count a and build the suffix for count b. And as you already built, then iterate, like you can consider it as almost brute force, but it is optimal. So iterate each index I from 0 to n. Why 0 to n? It's not n minus 1, because we want split n plus 1 split. So to iterate n plus 1, we need to 0 to n, so it will give you the n plus 1 split. Now consider at index I we split it. That means when we traversing the string at the ith positions, let's say this is the string over here, this is the characters given, and we are traversing these positions. That means we are splitting over here, and before this we just consider all a, and after this we just consider all b. So that means we just need to get that count. We already store that count in count a. It will count up to 0 to I, what are the number of a is there, and count b, and it will give you the I plus 1 to n. So and it will give you the number of deletions n minus, that will be the n equal to total number of elements minus count of a plus count of b. So it will give you the number of deletions required, and we just update the global minima. We just update the global minima over here, and at last we just return the global minima. You can say global minima, or it's you can say minima. Now let's come into the coding part. As I already discussed in the algorithm, it will exactly same written in the coding, and I show over here C++ code and Java and Python code. I will attach in the YouTube descriptions. You can go through there, and those are the code is exactly similar. So first of all, let's take n s dot length. Now take two vectors, that is count of a and count of b. That count of a is the prefix of for the count of a, and count of b is the suffix of count of b. Now let's fill this count of a. That means we are 0 to n, and if it is a, this expressions means s of I equal to a. If it is current value is a, then it will give you the true, that means it is 1, and otherwise it will give you 0. So accordingly it will add it over here, and similarly we just take it from the right to left. So that would be n minus 1 to 0, and it will update the count of b as suffix. That means if s of I equal to b, then this portion is true and it will give you the value of 1, otherwise it will give you the value of 0. So according to this value we just add it in the count of b. Now let's define a global minima, that you can say mean delete, and considering like initializing it in infinity, or you can say int max for the integer case. Now we iterate through the 0 to n plus 1, that means we iterate from 0 to n to consider the answers, like to do the split operations. So mean delete part will be mean delete equal to minimum of mean delete n minus count of I minus count of b. So it will give you the minimum number of deletions, and it will be there give you the current deletions required, and according to that we just return minimum delete at last. So now let's try to dry run an example. This is the first example. So you can consider count of a equal to, you can 0 1 2 3 4 5 and 7. So you needs 8 space array, 0 1 2 3 4 5 6 7, 1 2 3 4 5 6 and 7. So in the first positions, is it a? Yes, so count is 1. And second positions, like index number 1, it yes, so it will be 2. Then it will be b, it will go to 2, and then 3, propagate 3 3 and 4 and 4. Now let's update the count b. To update this one, 0 1 2 3 4 5 6, 0 1 2 3 4 5 6 and 7. Okay, and as it is already given, that will be like this way. First positions, its first positions is 0, and its last positions, that means plus 1, its last positions will be also 0. Now count the number of b from the right to left. So it will be at 7th position, yes it is there, so it will be like 1, then propagate 1, then 2, then 3, and it will propagate 3, then 4, propagate 4, and again propagate 4. So if you count, uh, 4 is there and 4 b is there, so yeah, it's correctly updated. Now run the I equal to 0 to n minus 1, 0 to n. Now try to compute for 0th answer. So what we do over here, we just check when we are at 0, we just check count of I and count of at positions. So if you look into the 0th positions over here, it will give you the 0. What it mean? It's mean that we want to take all b's over here. So at the 0th positions of at count b, it will give you the 4. What it mean actually? So these are the a b a b b a b. So we just want to take all b's over here, so we just delete all a, so we get all b's. If we want to count the for the 0th operation, so it will give you the 4, because here over here 0 and it is 4, and you needs you have the total 8 elements. So 8 minus 0 plus 4, it will give you 4 number of deletions required. And if you just let's take a random index, let's take an index number 4. So if you at the index number 4, there is 3, and at the index number 4 over here it's 3. What it mean? We just needs to like 4 at the index number 4. So answer would be the number of required deletions would be first of all 8 minus 3 and plus 3, so it will give you 2. So according to that, it will update the minimum deletions. Now let's come into the complexity part. So if you, for the time complexity, it will run big O of n time, it will also run big O of n time to update count b, and at last it will run also big O of n time. So you can consider it as big O of 3n time complexity, or you can say approximate big of big of n time complexity. And to see the space, over here we are taking big of n extra space, over here also. So we just take 2 extra space to compute the answers. So you can consider big O of 2n. So you can consider big O of n space complexity. But I will, in the next slides, I will show you the optimized versions of the space. Now come into the, if you look into these things, like look into this way. So we just need that previous counter of count A, count I, and the next counter of count B. So if we just to take two variables, then we can compute the answers. We do not need the whole array to compute the answers. So what I mean, let's take an variable count A and count B. Count A will simply count the number of A in 0 to I positions, and it will take the number of B I plus 1 to nth positions. These are the two cases. So first of all we update the count B, so it will similarly in minus 1 to 0, it will track all the count of the B, then take a global minimum as the previous code. Min delete is considered initializing as int max, that you can consider infinity at integer. Now iterate through the 0 to n, then as previous also we iterate, and accordingly we just n minus count A and count B. But here is the important steps, as we already track the in the previous code. If you look into the previous code, so we already update these portions, but these portions is compressed over here. This portions is compressed over two lines. What this mean? If we already process at ith positions, so we just need to process the next positions. To consider the next positions, we just add that in answers A, and if it is B, we just need to remove from that B, so that A is always track 0 to I, and B always track the I plus 1 to n. But if you look into this thing, I over here go to up to n, so you are thinking about it will give you, and we are accessing s of I, and you are thinking about that it will give you the out of bound access or segmentation fault in the C++ segmentation, but it won't give you segmentation fault. Why? Because the implementations of the string in C++, it will give you something like this way. Let's say string is a and B, so it will give you extra character, that will be \0. So this will give you the extra character, and due to this, if the string length is 3, it will now come into the complexity part. So as I already, so over here you can say time complexity would be big O of n, over here also big O of n, and so time complexity would be big O of n, which is similar the previous code, but the space complexity is optimized to big O of 1, because we are taking constant extra space, that is two variables count A and count B. Now come into the second solutions. This is interesting solutions, like this is a tricky part. How you can think about this way, that you can consider that B appears, if the B appears after A, that means first A then B, it's a valid substring, like valid string or balanced string you can say. So no deletions is required, that is perfectly fine. But if the condition is A appear before B, that means okay, I think B appear after A, yeah, A appear after B, that means after B, first B then A, this is not balanced, so we need to delete one. We have two choices over here. Either we can delete the current A, and then B is the valid balanced string, otherwise we just need all B previously so that it will be balanced. So you can consider this way. Let's take an example. So A B A, so when you process this A, let's yeah, it's fine. Where there are no b count, you consider as b count is 0 currently, so you can process it and go to the next step. It's already a, so no needs to increase the b count, and also it's a valid. If it is b, now increase the b count, it will be a 1. And if you again again go through this a, it's a not valid because b count is positive, and you consider you like you get the a. So either you needs to delete this a or needs to delete all the b you have seen. So we have two choices: delete current a, otherwise delete all the previous b characters. So what you can say, let's say we already processed, there is an array, so we already processed this much portion, that means 0 to I minus 1. And if it is s of I is equal to b, then no deletions is required. That means if we already calculate for this much portion and get the number of deletions required, so that will be propagated to the ith positions also, because at last b is valid, like there is either these conditions is achieved, otherwise these conditions will be achieved. But if it is s of I at ith positions, s of I equal to a, this is not valid. There are two choices, as I already discussed. Then if b count is there, then we delete the current a, otherwise delete the all previous b. So from this, combining this way, we can calculate the for the problem of 0 to I plus 1. So if we calculate the this much portion up to I minus 1, and according to these two conditions we can calculate the up to I positions. And similarly, if we process this I plus 1 variable, so we can process till I plus 1 conditions, and we can propagate till n. So that means if we have the value of the, let's say, problem solutions of up to I, we can propagate to I plus 1, I plus 2 and I plus 3 and up to dot 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 at the nth positions. That means it will be solvable by dynamic programming. Dynamic. Now let's come into the algorithm part. I think it's clear why I am saying that it will be solvable under the dynamic programming. Now let's come into the algorithm. So first of all, let's define the dp of I. That will be simple, like minimum number of deletions required to balance the substring 0 to I. Over here I is excluding and 0 is including. Okay. And next step is b count. We just want the b count, track the number of b counts in so far and iterate each character. You can, let's consider ch as the character, current character, and according to the conditions I give a previous slide. So if ch equal to b, that means no deletions required, just increase the b count. And if ch equal to a, that means current there is needs two cases. That means first case is delete this a, that would be like number of deletion would be the dp of I plus 1. That means whatever deletions done till this much portions, and if the current element also needs to be deleted, and it will be stored in dp of I. So we want to delete this one also, so dp of I plus 1, I plus 1 you can consider dp of I plus current number to delete it, and otherwise delete the all previous b count. What it means, we already seen some b and we just want to like contain the a part. Let's say there is b and then a, so we have the b count is 3 and we like encounter a. So what is the dp, you can dp of I plus 1, you can say number of deletions. That means we just want to consider a as element and just delete the all the b's over here. So that means you can say b count, but it means it will over here it's 3, and at last we just return the dp at nth positions. So according to the algorithm, I write the code over here. So it will be like int n equal to h dot length, then we take a vector that will be n plus 1 and initialized as 0. Now take a b count as I already discussed. Now iterate through each variables, and if s of I equal to b, that means you can consider, we do not need to delete anything, so just propagate over here. And in the dp of I plus 1, we just number of deletions required, we just tracking the number of deletions required, and just increase the b count. And if it is not, that means we encounter a. So do we have two cases, and whatever is the minimum, we take that. First case is we just delete current a, and second case is delete all the b we have seen so far, and at last return the dp. In next steps, okay, let's try to diagram, I think. Yeah, so over here I just show you a small portions of the diagram. It's because it's a dp, it will grow so far, like significantly high. So you can say, let's process this element, number of b count initially it's 0, and you consider this is an dp. So till now we just need 0, and again consider a, we do not need to do anything. If consider b, then dp count 1, and also needs no needs to element, no needs to delete any elements till aab, this is valid. Now you consider a. So if when you like encounter a, there are two conditions: either you delete a, that means it will give you minimum of 1, otherwise you delete all the b's, that will give you okay, yeah. So no, okay, first of all we have two conditions. First one is we have to delete either we can delete current a, that would be 1, and next we can delete all the b we have seen so far, that will also 1. So we minimum of 1 and 1, it will give you 1. So if you look into this part also, so over here either you delete this a, or a b a, you will delete this b. There are two conditions. Yeah, so let's come into the complexity part. Yeah, so complexity you can consider, we are traversing over here, it will give you the big O of n. And yeah, so time complexity, for time it will be big O of n, and for space it also big O of n. Why? Because we are taking a dp of big O of n extra space. Now I will optimize this space also, because if you look into this part, that means to count the dp of I plus 1, we just need the previous state. So why we need to store whole array? We just take a variable and count it. Like over here, let's take already b count taken. So mean delete variable is the actually represents the dpi. So if we iterate over here, so it will 0 to n. So if it is b, then just increase the b count, no need to touch mean delete functions. And if it is not, then we have two conditions: either mean delete plus 1, that means we erase current positions, otherwise b count, that so far we have seen all the b's. According to that, we just return mean delete at last. For over here you can consider the space complexity, time and space. It will be like over here we just iterating over here, so it will give you the time of big of n. It also same exactly as previous, but space is improved as big of 1, space complexity, because we are just using the constant extra space. Thank you guys, thank you for watching. Stay tuned for more videos, and I will attach the notes in the descriptions, and I also attach the LeetCode solution post in the descriptions. Thank you guys.